Hello everybody. Got home the other day from out-of-town trip over Thanksgiving and arrived home to a 50-degree house, which is a little surprising to us because we had the thermostat set for 60. In any event, this particular furnace right here was not running and it would not run. So the first thing I did was I looked into this inspection panel here and saw the fault codes. So the combination of blinking red and blinking amber lights indicated a number 42 fault code, not to be confused with the number 24. And on the back of the panel is a little cheat sheet. Number 42, inducer outside valid speed range. Indicates the inducer is not operating at the calculated RPM or has not started within 10 seconds after a call for heat. Check wiring to the motor, otherwise refer to the troubleshooting guide. Well, this thing has been running fine for 16 years, so it's not likely that all of a sudden I've got a wiring problem. But I immediately thought, inducer outside valid speed range. My immediate thought was, why is the thing out of the speed range? Next thing you should do if you're troubleshooting this situation in your home is turn off the power. In my case, I have a power switch right here, right next to the furnace, but you may not. Flip off the breaker, and I'll give you the standard caveat now. If you don't know what you're doing, you're not comfortable with electricity, or you don't understand gas combustion, or some of the basics, don't attempt to do this yourself, because carbon monoxide poisoning or electrical shock are things you don't want to have to be dealing with if you don't know what you're doing. So the first thing I would recommend you do is, once you've figured out the fault codes, is look at this draft inducer motor. The first thing you're going to be tempted to do is spin this shaft right here. You'll see there's a rotation arrow right here, so that gives you an idea what direction the rotation is. There's also a rotation arrow on the inducer itself right here. But before you do anything, before you grab that, this little disc you see here with the fins is a cooling fan. And the one thing you don't want to do is to push down on that cooling fan with too much force, because if that cooling fan moves from its current location toward the inducer, the back of that cooling fan will rub up against the electronic components that it's trying to cool, and it will create a noise problem for you, which is worse than the problem you already have. It's just going to make a bad situation worse. So be very careful about how much pressure you apply in that direction. In my case, I tried to rotate it, and it's been fixed already, but let me just show you here. So I just rotate it with your finger. You can very easily rotate it. Doesn't need a lot of force. Just twist it, and the inertia of the very large blower wheel should allow it to turn freely. In my case, this thing was very difficult to turn, and as a matter of fact, it would not do what you see right now. I can freewheel it, or I can just freely spin it. It will maintain some rotation. If yours won't do that, your initial thought is, I'm going to replace this entire draft inducer, and this version is no longer available, but it's been replaced by a new version. That thing is in the $800 to $1,000 range, depending on where you buy it online, and that's without labor. That's just the replacement part. And on top of that, you got to spend another $100 or so to replace these differential switches. And the reason these switches have to be replaced is because the new draft inducer, the way it's designed, doesn't have enough room for these to go back in the same location they were. This thing, as a matter of fact, the bottom of this differential switch is resting right up against the bottom of this cabinet, or the top of this enclosure here. So there's no room for this to move down, but the new draft inducer design takes up room, and so now they've gone with a plastic, I believe Honeywell differential pressure switches, which are a little bit smaller profile and will fit in the space that's available. What I don't understand is why they didn't just allow you to move this twist it sideways or move it to another location. But I'm sure they had a good reason for it, and I would not encourage you to go engineering this on your own. So that's what you're up against. You're up against anywhere from $900 to $1,100 worth of parts just to replace this whole draft inducer with the new assembly. But I was able to fix mine, and I'll show you what I found and how I solved my problem. So the first thing you need to understand is sort of the sequence of events in these high efficiency condensing furnaces. At least for my furnace, and I can't speak as to whether this applies to yours or not. This happens to be a Bryant, and therefore a Carrier is very similar. I also know that the train units, high efficiency condensing furnaces, used an ECM motor like this, as many other manufacturers did. The sequence of events is the thermostat calls for heat, step 1. Step 2, the draft inducer starts up to make sure that it's going to be able to exhaust the vent gases. And after the pressure differential switch determines that you have proper airflow and a certain amount of time has gone by, the igniter, in my case, I can view it through this window here, but the electronic igniter will turn on and start to glow orange, and then the gas valve will open, and then the gas will ignite, and I'll have my blue flame, and I'm off to the races in terms of heat. So that's the sort of the sequence of events. So you can see that if you have a draft inducer that's not operating, out of range according to the fault codes I had, and as you'll see in a moment here, it was not overspeed. It was actually failing to start. So therefore, it was out of the speed range. It was expecting some rotation. It was getting none. If you don't have the pressure differential switches happy, that there's a proper exhaust draft, which is created by the inducer motor and blower, then the igniter's not going to glow, your gas valve's not going to open, and at the end of the day, the symptom is you got no heat. Before we go any further, let me just apologize up front for this video might seem to jump around. I originally recorded some video as I was repairing the unit, and then I decided to go back and create some video at the beginning so you can see sort of the thought process and the solution process. So where we're headed with this is we're going to try to get this motor out so that you can lubricate the front, the drive bearing. So that's the bearing that's inside the blower housing, the inducer blower housing. And that in and of itself sounds like it's pretty simple. We're just going to put a drop of oil on that bearing. The problem is, rather than take the whole inducer assembly out, I've decided to just remove 6 screws. There's 1, 2 up here, there's 1 over here, and then there's 1 here, 1 in the center and the bottom. You can't see that, sorry. There's 1 over here, 1 in the center and the bottom, and then 1 back in this corner here. And what you're trying to do is separate the 2 halves. I actually detached the differential pressure switches to get them out of the way, disconnected 1 of these hoses, but just to get this assembly out of the way. Again, make sure your power's off, and what you're trying to do is separate this half of the inducer with the other half. I will warn you in advance, you see this white line running around down here? This is clear silicone RTV sealant, and it's used to seal, you can see it right there, and you can see some of it right in here. But it would run all the way down, all the way around the assembly. When you separate the 2 halves, you're going to break that seal, and you're going to need to redo it when you put it back together. And you need to break that seal in order to get the blower and impeller off and disassemble everything, so you have access to the bearing up here to be able to put a couple drops of oil on it. Getting a couple of drops of oil on that bearing allows this thing to rotate very freely and very easily. You can see that here in it. And I was able to get the unit running. It's running quite well. It's a little bit noisy, but not as noisy as it was before I got that oil on it. I've got it back together again, and I'm heating, but it's a little bit noisy, and I'm waiting for my new bearing to show up. So in the meantime, I've got a little bit of a water leak because I didn't put new silicone RTV in here, because I'm going to have to take it apart again when my bearings show up. So the only cost you're going to have in this to get this running again is you're going to have the cost of one or two 608 ball bearings, whether you're going to replace one or both. I plan on replacing one, but I bought two. You're going to get those easily for under $5. So the bearings are going to be simple. I don't know how easy it's going to be to get them off yet. I haven't gotten to that point because I don't have the bearings yet. But I wanted to give you a quick preview that you're going to need to be able to reseal these two halves, the front and back half. And I don't know how critical the RTV specification is, the silicone RTV. I haven't been able to find it yet. But I don't think you can just use anything. And then the bearings, I don't know yet whether they are single shield or double shielded, or single seal or double sealed ball bearings. I haven't been able to get a look at them yet to know, but my plan is just to replace them with double shielded bearings and take my chances with it. So wanted to give you that preview in advance so you sort of know where you're headed with this, and then you'll see my other video, which was shot well before I shot this video. So as I say, I shot some video while I was disassembling the unit and repairing it. And what you see right here is with the units all put back together again, and I'm heating. So that was my objective, to get heat. It's a little bit noisy, as I say, but I can deal with it right now. As I mentioned, I don't have the front and back half of the inducer housings sealed. So consequently, I've got a little bit of a water leak, condensate leak out the bottom of the inducer assembly while I'm waiting for my new bearings to show up. But what I've decided to do, and I just share this idea with you, I've got a little bit of a rag here, as you can see, just a small rag. I have it stuffed under the inducer housing where the water's dripping. And therefore, this sort of just acts as a wick. It wicks the water onto the cloth, and then the cloth drips down into a bucket. So it keeps the water from collecting on my floor. It's a controlled drip is the way to think about this. I'm controlling the drip and the flow of where the water leak's going until I can reseal it later, which I'll do after I put my new ball bearings in. Well, I've taken the draft inducer out of the furnace, and the first thing I notice is that this blower wheel, or this tangential blower wheel, seems to be a little bit stiff. In other words, it doesn't feel like the ball bearings are spinning freely. Or maybe there's something else binding here. That's the first thing I noticed. The second thing I noticed is, look at can't really see it, but it's not sitting square inside the housing. And as I look at it here, you can see that this bracket right here seems to be a little, bent. I don't really know how to explain that, because there's nothing that came in contact with this. This has been in the furnace for at least 10 years. I've had this furnace since 2002, and this is 2018, so it's 16 years. I did recall that they replaced the blower wheel. I don't know when, but I'm going to bet every bit of 10 years ago. So I'm wondering whether 10 years of use running in this wrong position here has created some crazy load or something, because the clearances obviously now are different on this end than they are on this end. But I'm going to take the wheel off. I'm going to put a little bit of oil on that bearing and just see if I can't get through a couple of days until I can get this replaced. Very interesting. Well, sorry I didn't film this, but I have the motor separated from the housing, and you can see this seal is in pretty rough shape. But what's also interesting is that it would appear that there's a lot of corrosion around here, and it would appear that some corrosion is definitely down inside onto that shaft and into that bearing. I pull this apart and see what's going on here. You can see this crud right here. See all this junk right here. I'm going to assume that that bearing is in not very good shape. So I guess I could try a couple different things. I could put a little bit of oil on it. That'll probably be very temporary. Let's see if I can focus this. So there's a lot of corrosion going on. It's coming, moisture, which is a lot of moisture in that blower housing, condensate. So that moisture has been able to get through that seal. That seal is not running in the right position. Because if this shaft is canted, not square, you can imagine the sealing's not very good. But you can see there's a fair amount of corrosion on here, and I'm going to assume that there's water down into that bearing, which ball bearings don't like to have water in them. Let me try to pack a little bit of grease in it, or put a couple drops of oil, heavy 30 weight oil on it. But I think the solution here is try to replace that bearing and square up this bracket right here. If I show that to you, you can see how that's not right. Okay, I've put 3 drops of oil on it. I just allowed it to drip in through here, and look at this. The shaft spins pretty freely. There's little resistance because you have to expect a little resistance because there are permanent magnets on this rotor, and there are spots where it wants to stop. So the magnets are slowing it down, but it's turning quite freely now compared to what it was doing before. It was not turning freely. So I don't know how long that's going to last, but it definitely explains the problem. I was not getting this draft inducer to start. Sometimes it needed just a little bit of help, and I would give it a little bit of help by spinning this end of it, and once I gave it some help to start, it would run, and then the gas valves would open and regular combustion would occur. So it's all about this bearing here, but to be able to release this bearing bracket, I've got to get the control board off. I don't want to do that yet. I'll see if I can get through the night. It's spinning quite freely now, and I'll square up this bracket here next, get it where it belongs so that the blower wheel's running true inside the housing. The only negative is that there's a special sealer that's required. It looks like a silicon RTV, but I know that it requires a special kind. There's a special spec for that silicone, and that seal's got to be really, really good because you don't want any carbon monoxide combustion gas leaking through this blower housing, not exiting where it's supposed to be exiting. Hey, sorry about that, folks. I was talking about the RTV seal that's here. I was pointing to the wrong side of the housing. I had it flipped over at the time, so didn't want to confuse you. Got the blower wheel back on, and you can see that now it's parallel to this surface right here, and it also spins pretty freely compared to what it was. It definitely sounds to me like a ball bearing, and the bearing's shot. It's still going to be a little noisy, but at least the furnace is going to start and run now because I freed up the motor shaft. So that's a huge improvement. We'll have heat tonight. Well, I've completed my repairs and the thing started up immediately. It's running. It's a little bit noisy, but it's running. Sure enough, that bearing with 3 drops of oil on it, it's got it completely freed up. It's a little noisy, so I'm sure the bearing's shot. In the meantime, I've got my CO detector here, an extra one sitting close by, just to keep an eye on the carbon monoxide in case I've got any leaks coming out here while we're running. But you can hear that bearing knocking around a little. But at this point in time, it's noisy, it's performing. I don't think there are any safety issues here. I haven't bypassed any other safety things, so the gas is not going to ignite if you don't have a draft. There you have it. I hope that helps you. This helped you. A subscription will definitely help me as I continue to try to get to 1,000 subscribers. Hey, good luck. Be safe. If you don't know what you're doing here, don't attempt this on your own. You don't want to electrocute yourself or cause a carbon monoxide poisoning situation in your house. So if you don't know what you're doing here or don't understand the concepts, hire a professional. This video was just to show you what I did and how I figured out what was going on to get my draft inducer running again.